Hello, my dear students, and today I am going to tell you a very interesting question which is based on infinite limit. Okay, see here. Here, the highest power of x in the numerator is m, and the highest power of x in the denominator is n. So, how to solve this problem? And practically, this is a formula. And first of all, I am going to derive the this problem, and after that I will apply this one to different problems. So that how to find out the questions easily. That means without solving the problem, you can get the answer. Okay. So let us see here how to solve this one. Limit x tends to infinity. Let us take common from the numerator x to the power m. If I will take x to the power m common, then this will become a0 divided by x to the power m plus a1 divided by x to the power m minus 1, because x will cancel out from the numerator, plus a2 by x to the power m minus 2, and last term it will be am. Clear? So similarly, let us take the common x to the power n from the denominator. It will become b naught by x to the power n plus b1 by x to the power n minus 1 plus b2 by x to the power n minus 2 plus bn. Okay, so let us write it in a systematic way. Limit x tends to infinity. This quantity, this one, I am writing separately. This will become x to the power m by x to the power n. It will become x to the power m minus n. X to the power m by x to the power n, it will become x to the power m minus n. Okay. So into limit x tends to infinity, I am writing the rest part. A naught by x to the power n plus a1 by x to the power n minus 1 plus the last term is am divided by b naught by x to the power n plus b1 by x to the power n minus 1 plus bn. Clear? I have separated these two parts. And now see here, very interesting thing is that now if we put x is equal to infinity, this term will become 0, because a naught by infinity will become 0, this one becomes 0, and only remain this term. Similarly, denominator, this term will become 0, this term will become 0, only bn will remain. So I am writing this one as is equal to limit x tends to infinity x to the power m minus n into the numerator will become am and the denominator will become bn. Here, now here there will be three cases, because actually here m and n belongs to z. Both are integers. M and n are integers. Okay, so let us see. Now there will be three cases. That means m can be greater than n, or m will be equal to n, or m can be less than n. There will be three cases. See here, this is a constant. Am by Bn, this is a constant. So we can write here, after that I will write here inside Am by Bn whole into this one. See here, if m is greater than n, if m is greater than n, that means m minus n will be positive. And if m minus n is positive, that means x will remain in the numerator. That means see here, if x to the power minus 2, it will become 1 by x square. That means x will come to the denominator. And if the power will be positive, then x will remain in the numerator. Okay. So see here, in the first case, if m is greater than n, that means this power is positive. That means x will remain in the numerator. So if x tends to infinity, so this will become infinity. Okay. And if m is equal to n, that means this power will become 0, and x to the power 0 means 1, and limit of 1 is 1. Here. And if m is less than n, that means the power will become negative. If m is less than n, that means smaller number minus larger number, it will become negative. That means x will come to the denominator. So x to the power m minus n minus m. So now as x tends to infinity, this term becomes infinity. That means this total term will become infinity. And 1 by infinity it is 0. Clear? So if there is any doubt, then please tell me. Now multiply this one to these three cases. Infinity into this one is infinity. Under which condition? If m is greater than n. And this one into 1. That means am by bn when m is equal to n. And this one into 0, it will be 0 if m is less than n. So these are the three cases. That means see here, m is the degree of numerator, m is the degree of numerator, and n is the degree of denominator. If m is greater than n, if m is greater than n, that means if the degree of numerator is greater than the degree of denominator, then the answer will become infinity in this case. And if n is equal to n, that means both the degree will be same. That means the coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. Numerator, am is the highest power of x in the numerator, and bn is the highest power of x in the denominator. Answer will be am by bn. Clear? And if the degree of denominator is more, then the answer will become 0. Okay. So see here, I am giving examples. How to write the answer directly? Limit x tends to infinity, 3x square minus 4x plus 5 divided by 7x square plus 2x minus 1. Here the degree is same. The degree of numerator is 2 and the degree of denominator is 2, and this is an infinite limit. So as I have told you, the answer will be 3 by 7. That means the highest power of x in the numerator divided by highest power of x in the denominator, if the degree is same. Okay. So see here, another question. Limit x tends to infinity, 3x square plus 5x plus 1 divided by 7x minus 2. Okay. Here the degree of numerator is more than that of the denominator. The degree of numerator is 2 and the degree of denominator is 1. So in this case, the answer will be equal to infinity, as I have derived. Okay, see here. If m is greater than n, the answer will be infinity. M is greater than n, so answer is infinity. Okay, another question. Limit x tends to infinity. 3x plus 5 divided by 7x square minus 4x plus 2. Here the degree of numerator is less than that of the denominator. So answer will be equal to 0. So these are the three cases for the above problem. Okay. So from the very beginning I have told you, this is not the problem actually, this is a formula. This is an infinite limit, the numerator is a polynomial and the denominator is also polynomial. So it depends, the value depends upon the degree of numerator and denominator. If the degree of numerator is greater than the degree of denominator, in case of infinite limit, answer will be equal to infinity. And if the degree of denominator is more than that of the numerator, then answer will be equal to 0. And if degree is same, if the degree is same, then highest power of x in the numerator divided by highest power of x in the denominator. That will be the answer. Okay. So I have already given three examples. See here. These three examples. Here the degree is same. So highest power of x in the numerator divided by highest power of x in the denominator. 3 by 7. Here the degree of numerator is more. All these are infinite limits. See here. Here the degree of numerator is more. So answer will be infinity. Here the degree of denominator is more. So answer is 0. This is all about this problem. Okay. Thank you.